We'll start the session. So people who are joining later, may let them join. Uh, my screen visible? Hello, is my screen visible?
Yes, sir.
Okay. So just to give an introduction, since these videos will be on public forums and many people other than those who will be attending here might see this. So welcome to the week 11 of the problem solving session for the course Geotechnical Engineering 1, handled by Professor D.N. Singh from Department of Civil Engineering, IIT Bombay. So I am Yogendra Narayanan. I am a PhD research scholar under Professor Singh. So who will be handling this? Who is handling this session uh, for this period? So essentially, uh, uh, I would like to reiterate that these sessions are essentially to make the learners proficient in understanding the concepts that has been taught during a particular week uh, by means of solving problems from the previous assignments and some other questions, and uh, solving the questions by which you can get the necessary uh, exposure to approach the problems, which will be helpful in solving your weekly assignments as well as uh, your course examinations, which will be held at during April May. So with this, I would like to give a small recap of the contents that has been covered in the week 11 of this course. So week 11 essentially introduced the concepts of compressibility of the soil and what are all the factors governing it, and what type of soils undergo compressibility, the various terminologies related to compressibility, various concepts, essentially uh, coefficient of compressibility, uh, coefficient of volume compressibility, compression index, etc. And uh, we have seen the differences between these coefficient, how uh, the settlements in the soils can be analyzed by laboratory methods, uh, by oedometer method, and how to analyze those data, and followed by uh, the at the towards the end, a lead was given to Terzaghis one-dimensional consolidation theory, which will be covered in the further remaining 1 week of this course. So I think this is the penultimate session for this course, and the concepts covered here are one of the most important in the context of geotechnical engineering and soil mechanics, which will be useful in further studies who are from civil engineering backgrounds. And uh, with this, uh, this session will be solving some of the conceptual questions first, and the difficulty will be from simple to some uh, real life or translated real life problems we can try to solve. So I would like the participants to actively involve in solving the problems by responding uh, to the queries which I may post. So with this, I think we can start the session. I hope the screen is visible again to just confirm it. So is my first two questions visible?
Yes, sir.
Okay. So the first question is fairly simple. what all the factors affect the compressibility of a soil mass? What are all the factors affect the compressibility of the soil mass?
All the above, sir. State of the soil, type of the loading,
Okay, the other
and type.
person.
Sir, D only.
Okay. So as you both said, it is option D. So state of soil mass, which will be we can define as NC or OC, under what type of consolidation or stress history the soil has undergone, and type of loading is uh, how the existing loading, whether it is getting loaded or unloaded. So loaded in the sense there can be an external load due to for buildings or uh, any infrastructure that is being constructed on the ground, and unloading in the sense excavations, etc. So that also depends, affects the compressibility of the soil mass. So type of mineral present, that is one of the primary governing factors, because type of minerals are associated with the nature of the soil present, whether it is sand or clay, which are primarily differentiated by sizes and type of minerals. So hence the option will be all the above. So coming to the second question, compression of soil could be due to.
Expulsion of air,
Okay,
reoriented of the grains.
any other guesses?
Expulsion of water also.
Okay,
Reorientation of grains. All the above.
Sir,
yes,
is expulsion meaning same as exclusion?
yes, removal.
Then all of the above, sir.
Okay, so here you might get confused. uh, Here the term is compression. So first, uh, when a loading is applied, first a part of air will be removed, followed by pour water, expulsion of water, which is consolidation, primary consolidation. That is primary consolidation. And this reorientation of grains is a phenomena which is referred to as secondary consolidation. So in general, all three are responsible for reduction in volume of the soil, which is referred to as compression. So compression in the sense here we regard this as decrease in volume of total volume of soil. So and we assume that it will be decrease in volume of what? Reduction in total volume will be equal to reduction in volume of,
Voids.
it will be reduction in volume of voids. So because we consider solids as incompressible. So they don't undergo volume change when we apply external load. So solids are incompressible, and the reduction in uh, total volume of soil will be the reduction in volume of voids. Hope this hope this is clear, right?
Yes, sir.
So moving on to the next question. The first question, the radial strain in oedometer test with a ring diameter d is. Radial strain in the oedometer with a ring diameter d. Any guesses? Any guesses? Hello? Am I audible?
Yes, sir. It's audible.
What do you think is the answer for the question? Radial strain in the oedometer test with a ring diameter d is?
Critical stuff and returns and wait a minute, sir.
Let me explain. So now you consider an oedometer ring. So this will be the oedometer ring. If you see from a front view, so its diameter is d and its height is, let us say, capital H. So now what we are doing is we are applying a load. It is we are applying a stress, which will be uniformly distributed over the entire ring, which is, let us say, sigma dash. Now what will happen? What will happen when you apply load?
Compression,
Compression. In which direction?
vertical, compression in horizontal, vertical,
Horizontal or vertical?
compression in vertical, sir.
Vertical. Why not horizontal?
It is a confined. It is a confined. So that's
Yes. So it is a rigid boundary, right? So these three are rigid and soil is allowed to compress in only
vertical direction.
one direction. That is, here it is vertical, right? So what is the question here? Radial strain. There are two strains. When, what is meant by strain?
Change in length by
Yes, change
initial length.
in length by original length. So in this case, in vertical case, it will be delta H by capital H. This is known as
Delta
longitudinal strain.
longitudinal.
Longitudinal strain. And delta D by D is known as radial or lateral strain. All right.
Yes, sir.
So now try to tell what is the radial strain for oedometer test.
What's 0?
It is 0 because
0.
due to the application of load there is no change in diameter of the ring. So it will be strain you will be expressing in terms of epsilon. So radial will be R. Radial strain will be 0. Okay.
Yes, sir.
So now we will move to the next question. The D
The
by H, that is D is to H ratio has been taken as 3 in the oedometer test because vertical stress is 3 times the horizontal stress is 3 times the vertical stress, all the stress bulbs are confined to sample would be 99%. Generally the soil has a specific gravity of close to 3. Which what option do you think is the right option?
H is the లాంగ్ ట్రైన్ కాబట్టి horizontal stress D by H equals to 3 అంటే దీనికన్నా ఇది ఎక్కువ ఉండాలి కదా. చిన్నది vertical stress, horizontal stress is 3 times that of the vertical stress.
Option which is the right option?
No idea, sir.
Yeah. So here the D is to H ratio in the oedometer test
Is
is
equals
always
to
taken as 3. That is H will be 1 by 3 times of diameter. Generally the oedometer ring will be 6 centimeter in diameter and 2 centimeter in height. 6 centimeter in diameter and 2 centimeter in height. So the primary reason for choosing this ratio is the as you know in the last week you have been taught the pressure bulb concepts, right?
yes, sir.
So this entire uh, dimensions or the ratios of dimension are chosen so that when you apply the external load, the stress bulbs which are getting generated will be confined to within the confined up to 99% almost within the given height and diameter. So in the lateral and longitudinal extent, the stress bulbs will be confined within the sample about 99%. So that is the reason why this value is taken as 3. Okay.
Okay, sir.
So the right option is C. So now try to answer the third question. If the pre-consolidated consolidation pressure is 50 kilopascal and the pressure acting at present is 45 kilopascal, the soil is in which state? Are you able to understand the question?
Yes, sir. It is OCC soil, over consolidated.
How you are saying?
So pre-consolidation press already 45 kp pressure already the soil take out of
So how will you quantify the term which is asked
sir.
here? Hello?
Yes,
Yes.
sir.
How will you quantify the term? By which term you will say whether it is in normally consolidated state or over consolidated state or under consolidated state?
Yes, sir.
How will you say?
Uh, so before the present pressure 45 kPa already the soil and I don't know how to tell in English. Already that pressure was taken before.
Yes, you are right. Conceptually, you are right. So we define the term as over consolidation ratio, OCR, which is pre-consolidation pressure by
At present pressure.
present pressure.
Pressure.
So if you uh, in a logical sense or in a subjective sense when we talk, so the soil has already been exposed to 50 kilopascal, but right now the stress acting is only 45, so it has not reached its actual capacity, so which renders the soil as over consolidated clay. So the option is OC. Now mathematically how we'll express this, we'll divide
50
50
by 45.
45, which
It's less than
is
1.
10 by 9. It is greater than 1.
Uh-huh.
So when OCR is greater than 1, we term this as OC soil or consolidated soil. All right.
Yes, sir.
Now we will move to the next question, which holds not true for compaction and consolidation. Which is not true for compaction and consolidation. This is fairly simple.
Compaction and First one is not true.
Why?
Dry unit weight increases in both the process.
It should increase, na? Why it will increase?
Not true.
Okay. So as per you, it is not true. Then
Sustained meaning means
sustain means continuous loading.
continuous loading.
That is the loading is there for long time.
Oh, okay. B is all B wrong. because
Okay.
compaction is instantaneous loading.
Okay.
Okay, in compaction, the air is expelled while water is expelled. I think B is wrong.
Okay. C and D.
Consolidation soil mass is saturated, so
That
that is
is
correct.
true.
In compaction,
This
the
is
air is the air is expelled, water is expelled out. C is also correct.
C is correct.
Also correct.
B, as you said,
Wrong.
compaction is due to instantaneous loading and consolidation is due to sustained loading. So B is wrong.
Wrong.
Now what happened to A?
A dry unit.
So in compaction, how will you express compaction characteristic curve between which and which you will plot?
What's ask once.
So am I audible?
Yes, sir. It's audible.
So we have studied compaction, right? Hello.
Sir, tell me, sir.
We have studied compaction, right? We
Yes,
have
sir.
solved some problem also.
Yes, sir.
So during compaction, we used to draw one curve
Yes, sir.
between which quantities we used to draw one curve.
Op, uh, OMC.
OMC is the term that you get from the compaction curve.
Dry unit weight and water content.
Yes, you draw between dry unit weight and
Water content.
water content. Now the curve will be fairly like this, right? So when you are within the, this is, let us say OMC. So in the dry of optimum, the dry density is increasing during compaction. So
Okay, okay, okay.
for compaction, gamma D is
In,
increasing.
increases.
Now coming to consolidation. Uh, Now let me ask you, what is the relationship for gamma D? How will you calculate gamma D?
Gamma D is equals to gamma W
Okay,
into G
okay,
by 1 plus E.
1 plus
E.
E. Right. Now during consolidation, what is happening?
Excess pore water pressure is decreases.
Then which leads to,
What's which?
you are saying, you have said rightly that pore water pressure, excess pore water pressure is expelled,
Yes,
right?
sir.
So during that, that is due to that expulsion of pore water pressure, what is happening to the soil mass?
So, decreases in the void rush.
You are right. So void ratio
Decreasing.
decreases. Now if void ratio decreases, what happens to the gamma dry?
Increasing.
So gamma dry will increase in case of consolidation also.
Okay.
So this option is right.
Okay.
Okay.
Okay, sir.
Now, did you understand this?
Yes, sir. Understood.
Yeah. Now coming to the next question. The spring analogy states that pore water pressure will increase while the effective stress will decrease with time. Pore water pressure will decrease with the effective stress increasing in time. Pore water pressure will decrease while the total stress will increase. An increase in effective stress will decrease the total stress.
Okay, pore water pressure will pore water pressure will increases effective stress increases. Okay, B option, pore water pressure will decreases while the effective stress will increases with the time.
Yes. So this is true.
Yes, sir.
Then which quantity will be constant?
Total stress is constant.
Total stress is constant.
Constant.
So this is true. So I think here no need for further explanation.
Yes, sir.
So now moving to the next question. So when the primary consolidation process in a soil is complete, then
Sir, I have a small doubt. In a
yes,
spring analogy, in a spring,
yes,
uh, uh, we we think about soil mass
hmm.
in geotech. That is, in a spring analogy, the spring
Spring is treated as soil skeleton.
soil skeleton. Okay, sir.
Hmm. So coming to the next question, when the primary consolidation process in a soil is complete, what is the condition that is existing?
Ex- excess pore water pressure will become zero.
Okay. Any other options?
Hydrostatic and hydrostatic pressure means
That is existing pore water pressure.
existing pore water pressure.
So
I don't
pore
know any idea, sir.
pore pressure or hydrostatic pressure or neutral pressure. So these terms are all used to denote the water exert pressure exerted by the water in the pore. So now you consider a soil mass which is completely saturated, right? Now it is of some gamma and let us say it is under and water content, some water content which is such that the soil is saturated, then some void ratio. All right, now let us take a point here. Right, now consider this as water table also, and this is ground level also. So what will be the pore pressure here? Let us say this is at a distance of z. What will be the pore pressure at that point?
Gamma W into Z.
Gamma w into z.
Z.
Now it is, that is u initial is gamma w into z. Now what I am doing is I am applying a semi-infinite load. Now what will happen to the pore pressure?
Pore pressure increases.
So pore pressure will
Increases. Water
some
will decreases.
delta u, right? When this delta u is there, and then what happens is water slowly starts to dissipate out of the soil mass.
Yes, sir.
So at the end of consolidation, what will happen? Delta U will become 0, right?
Excess pore water pressure is 0.
That is delta U. The
Yes.
excess pore water pressure, that is pore water pressure developed due to the external loading. So that is 0.
Okay.
But this will be existing only,
Okay.
right? After consolidation, this is the initial hydrostatic pressure. So this will continue to act, whereas the external excess pore water pressure will tend to 0. So this option will be wrong, and this option also will be wrong. Effective stress will become 0. So this is obviously not right, because effective stress tends to increase.
Oh
So this
no.
is wrong. So eventually this is obviously the right option, right? Understood or not?
Sir,
Yes.
I have a small doubt. If the load is applying, so
Hmm.
excess pore water pressure will decreases. Okay, but normal and hydrostatic water
Hmm.
or existing water is also uh, out from the out.
But
So the
this,
water is also decreases or not, sir?
wait, so water is coming out, but
Yes,
where
sir.
where the water will go? It will be standing here only, na? Unless you pump the water out, you will not experience a decrease in pore pressure. So in an ideal case, so what I told, once the fluctuations are there in water table above the ground level, there is no change in the column, will be gamma W by Z only, right? See, now let me explain pictorially. So this is the initial condition, this diagram, right?
Yes, sir.
Now after consolidation, what will happen? So let us assume this is this was the initial portion, and it the soil mass got reduced to this much, right? And water is expelled out up to this height. So when you consider the same point here, the height of the water column will remain same only, right? Unless you remove this water by external means.
Okay, sir.
Understood or not?
Understood, sir.
Now what will be the pore pressure here?
The gamma W into Z.
So there is no change. So
But if
the
in case loading is applying,
this is after loading only.
okay, the water is
Water is coming up. See, did you understand or not?
yes, sir, understood.
See, assume a sponge is completely filled with water, right? And you are placing that sponge into a container, and you are applying a load.
Yes, sir.
And when you apply load on the sponge, what will happen? Water will come up
Yes, sir.
out of the sponge, and
Yes.
you are not removing the water.
Okay.
So what will happen? The water will remain there only, within the container only.
Okay, okay, sir.
So that's how, when a soil is compressed, when the pore water is coming out, unless it is removed, this column will be remaining the same. So before and after consolidation, the initial pore water pressure, uh, which is being exerted on the soil, will remain the same, whereas the excess pore water pressure will tend to 0. So this option will be right. All right.
Yes, sir.
So coming to the next question, which of the following soil types will exhibit minimum settlement upon loading?
Minimum settlement over consolidated clay.
It will be over
Over
consolidated clay,
consolidated.
because clay is silt, there is a component of clay which will undergo this one, and this is sandy clay, so it will also be undergoing this one. Normally consolidated and over consolidated clay, obviously we know that NC material will undergo larger settlements, right,
Yes, sir.
compared to over consolidation clay. So based on this question, we will be solving one problem, so that you will be understanding in a that is in a actual situation, how the over consolidated clay is having lesser settlements. All right.
Yes, sir.
So now coming to the next question. So Terzagh's consolidation theory is applicable to one-dimensional consolidation test for which conditions?
Small load increment.
So you are right. So it is obviously applicable to small load increment ratios. So coming to the next question, which of the following can lead to pre-consolidation of a clay layer? One is desiccation, second is withdrawal of a glacier, rising of water table, and fourth, removal of construction load.
I don't know, sir. Rising of water table, I think, but I don't know exactly.
So desiccation of upper layer is getting desiccation is cracks.
Cracks.
So the right options for this which can lead to pre-consolidation is uh, see, for at a time t equal to 0, it is 0. Let us say the stresses acting on the soil mass is sigma, and when I am saying lead to pre-consolidation of a clay layer is, you are reducing the load such that it becomes an over consolidated soil. So at t equal to t1, let us say this is sigma 1 dash sigma naught, let us say sigma 1 dash is greater than sigma 0 dash, so such that it becomes a over consolidated clay, and then at time t equal to t2, you are removing the load such that it behaves as a over consolidated soil. So here it is NC and here it will be OC. So we have to look where there is a removal of soil mass such that there is a decrease in effective stress. So that will happen when a glacial load is decreased, removal of construction load, which will obviously decrease the effective stress, and rising of water table will obviously decrease the effective stress. If that is getting decreased, the stress experienced at that time will be lesser than the sigma 1 dash, right? So these three options are right.
Okay, sir.
So moving to the next question, which among the following is correct with regards to NC and over consolidated soils?
Over consolidated ratio greater than 1 for OC soils.
Okay.
No. Only B.
Only B.
Yes, sir.
What about this one?
What, sir?
So now let us analyze these three
Okay,
options.
greater, less than 1 NC soil.
Less than 1 is obviously
NC soil.
less than or equal to 1 is NC. So
Equals to 1 are told to under consolidated.
okay. So that is also a part of NC only. So
Okay.
here in this case, how will you see the question is that OCR equal to 1. That is the pre-consolidation pressure is equal to the applied pressure, applied stress, right? Right or
Sir, what?
see
Hello?
OCR equal to 1 means pre-consolidation, the applied stress will be equal to pre-consolidation stress, right? Am I audible or not? Person who has joined now, you can continue from the next question. So, so when you say which among the following is correct with regards to NC and OC soils, so obviously this is wrong. That is wrong means does not apply, which is exactly opposite to the definitions of OC soil. And OCR is greater than 1 is obviously right because OCR we define as, how will you define OCR? Can anyone answer? How will you define OCR? Over consolidation ratio. So over consolidation ratio is the maximum pressure experienced in the past by the maximum pressure experienced at present. So when this is greater than 1, that means the soil has undergone a larger, has experienced a larger stress before more than the present one. So that is OCR is greater than 1 for OC soil. Now the moment OCR equal to 1, which is the external applied pressure as well as the maximum experienced pressure are equal the moment it uh, achieves. So it will change into a, it is the point of change from OC to NC. So these two options are right. So this is the right option. So moving on to the next question, I would like you to solve this question, and that is actively solve the question and tell me the answer. So Let me tell the question. A soil when loaded from 100 kPa to 500 kPa, the voids ratio changed from 1.05 to 0.95. What is the compressibility index of the soil? Can you solve the question?
Yes, sir.
The other person, please respond. So what is compressibility index?
Change in void ratio by log of sigma effective at final by sigma initial effective.
That is right. So how will you define compressibility index? By how will you denote it? Symbol
CC.
Cc. So now we are supposed to calculate Cc, which is delta E by log of P. Sorry, we are denoting as what? Sigma 2 dash by sigma 1 dash. Now this is the curve between E and log sigma dash curve. So it will be fairly a straight line. So its slope is Cc. So now if you substitute the values, 1.05 minus 0.95 by log to the base 10, 100, sorry, ln. This is log natural, log to the base E by 100. How much you are getting?
Zero 0.05.
So this will be 3.1, right? 0.1 by ln 5. How much you are getting?
0.05 is
So
not right.
0.1, this is log to the base e, that is natural log. Calculate it once. 0.1 ln phi is, I think,
Oh, sorry, 0.14. CC is
see,
equal to 0.14.
0.14 you will get when you give it as log to the base 10. So you have to put it the natural logarithm ln phi. So it will be approximately 0.1 0.1 divided by 1.61 will be
6.
0.062. What is the unit?
Unitless.
It is not the, it does not have any units. So moving to the next question. So I think the figure is visible, right?
Yes, sir, it's visible.
Figure is visible. So here there are two curves for soil 1 and soil 2, and they have been plotted in a plane of E and sigma dash plane, and four options are given. Now what is being asked is, from the figure what can you conclude? From the given figure, what can you conclude from the given options? Any guesses or any idea how to approach this?
No.
The other person, Miss Meghala. Okay. Now let us analyze the options. So
Let it.
first let me take the options C and D. So what they have said is coefficient of consolidation. D also says coefficient of consolidation. So this coefficient of consolidation will be, please listen carefully. The coefficient of consolidation, it is not compressibility index or coefficient of compressibility or coefficient of volume compressibility. It is not that. It is a separate term, coefficient of consolidation, which will be introduced in the Terzaghi's one-dimensional theory of consolidation. So it is, coefficient of consolidation is denoted as CV, which is time dependent. It depends on time. So from the given graph, do you have any data about time?
No, sir.
So these two options are obviously eliminated, right? Now coming back to the options A and B, here less compressible and less compressible. Less compressible in the sense, what does it convey?
Less reduction in volume is
That is,
small.
if reduction in volume, in this case, what is that?
Wide ratio.
delta V can be analogous to delta E, right?
Yes, sir.
So now for option A, you write in terms of mathematically, you write delta E for 1 is less than delta E for 2, right? Am I right or wrong? Please respond.
Why, sir?
See, soil 1 is less compressible, then obviously the option A. See, just I am converting the statement to a expression.
Okay. Okay, sir.
So soil 1 is less compressible than soil 2 is this one. Delta E for 1 is less than delta E for 2, right?
Yes, sir.
Now second option is delta E for 2 is less than delta E of 1. These are the two options which we need to analyze. Now look at the graph carefully. Now I will say how to analyze it. So what I will do is, to analyze the compressibility, we need to keep this as constant, right?
Yes, sir.
So what I would like to do is, I would like to draw a line here. Straight line, and here also, right?
Yes, sir.
Okay. Now this is point 1, this is point 2. All right. Now this is soil 2 and this is soil 1, right?
Yes, sir.
Now let us consider when the effective stress is increasing from 1 to 2. Okay, let this be 50 and let this be 100 kPa. All right. Am I clear or not?
Yes, sir. Clear.
Now
Bluetooth mode.
what I will do is, I will keep the increment in effective stress as constant. Listen to my words carefully. When the effective stresses increases from 50 to 100, first let me take soil 1. So this is the change in void ratio, right? Delta E of 1, right or wrong?
Right, sir.
Now coming to the second soil, so this is delta E of 2, right?
Yes, sir.
Now what is the relation between delta E1 and delta E2?
Okay.
It is visible from the figure. What is the relationship between delta E1 and delta E2?
Okay, relation.
Relation in the sense which is greater or which is lesser.
Okay. Delta E1 is greater than the delta E2.
So which of the option?
Option B is correct.
Option B is correct.
Correct.
That is, when you increase a load, the volume change undergone by soil 2 is lesser than the volume change undergone by soil 1. So that is what is being expressed in the figure. So the right option is option B. Am I clear?
Yes, sir, it's clear.
The other person, any doubts? If you have any doubts, you are free to interrupt and ask me. So if you are not convinced, or if you are unable to understand, please don't be quiet. You
Yeah,
can
sir.
ask.
Clear, sir. Clear, clear.
Okay. Now coming to the next question. If the compressibility index of a soil is 1.26, what would be its liquid limit? So what is the relation? You have to use this Kempton's
CC is
relation.
equal CC is equals to 0.09 into WL minus 10.
0.009
9
into liquid limit minus
minus
10
10%.
percentage. You have 1.26 here and 0.009 into liquid limit minus 0.09. Solving this, how much you are getting?
10% means 0.09. Okay, 10%,
140.1.
Hmm. So it will be approximately 140 percentage. So it is highly compressible clay, right? Now coming to the next question.
Sir,
So yes,
sir, once check the previous answer.
how much you are getting?
150.
Then just let me check once.
Okay.
Oh, so it 150.
Yes, sir.
It is 150 percentage, right?
Yes, sir.
Now moving to the next question. So a figure is given. So and each figure is denoted as each curve is denoted as A, B, and C, and there is a and all the three curves are stresses, and here you have been given some options. So now you have to match which one. Did you understand the question?
No, sir.
Hmm?
No, no, not understand, sir.
See, Are your figure is visible, right?
Yes, sir.
And what I have given is in the right side in the table, I have given three options. That is two columns I have given, which denotes symbol of the curve and what does it denote. Now I want you to match the symbol and item correctly. So what does A represent? Whether it represents pore water pressure, total stress or effective stress variations. What does B represent? What does C represent? That I would like you to know from you.
Where A is the total stress and
A,
B is the hello.
yes.
A is the total. A represents the total stress. B is the pore water pressure, and sorry. Uh, right. B is the pore water pressure, and C is the effective stress.
C is the effective stress.
Yes. What?
So see A is
Sorry,
dotted.
sorry. Okay. A where A is the effective stress and C is the total stress.
So
ABC is not.
is it right?
Yes, sir.
Any other guesses or any other views? Okay. So always during consolidation with time, pore water will decrease. So B represents pore water
Pore
pressure.
water pressure
And when pore water pressure decreases, effective stress will increase.
increases
So A will be
effective stress.
effective stress. And even though these two varies, this will be within the limit of total stress. Total stress will be remaining constant. So C is a constant. C does not vary with time. So C denotes the total stress. Hope it is clear.
Yes, sir.
Now coming to the next question. The following results were obtained from a one-dimensional consolidation test. What will be the Voigt's ratio for a 1000 kilopascal stress? Try to solve this. I will be back in a minute.
Okay, sir.
Did you try to solve? Or you are facing any issues? Hello?
I will solve.
So now what is the term you need to find out here?
CC.
So first you have to find out CC. CC is equal to E delta E by logarithm of sigma 2 dash by sigma 1 dash. So it will be 0.95 minus 1.2 divided by natural logarithm of 600 by 200. It will be equal to 0. Minus 25 by ln t. 0.25 divided by ln t, which is how much you are getting?
0 0.22.
Yes. So since it is a slope, so you can get uh, so let us keep it as uh, this negative sign itself. Generally it will be, why it is negative means, so you are plotting log sigma and E. So you will get a curve like this. If a line is like this, what will be the slope? Slope will be negative, right?
Yes, sir.
So that is the reason we are getting a negative slope here. So, but when you report the value of CC, you will be reporting it as a positive value only, 0.228. Now, what we need to know is what will happen to the void ratio for 1000 kilopascal. Now, what will you do?
Uh, Replace in CC value 0.22, and we
0.22
to
we will keep the
and
negative sign as the same, and
S.
we don't know the final E.
But initial value we take one of them. One of
Yes,
them.
let me take it as 0.95 divided by divided by ln of 1000 by 600. Or if you want a whole number here, you can do it with E equal to 1.2 also.
Okay, sir. Answer is 0.833.
So E will be E at 1000 kPa will be
8
0.833.
3.
Have you understood?
Sir, once there,
Where did you get stuck?
E minus 0.94.
Yes. Okay. So you listen carefully here.
Okay, sir.
So now, did you understand how we calculate CC?
Yes, sir.
Now what you know, what you want to know is, you have earlier we have been given from 200 to 600 when it is increased, E decreased
Yes.
from 1.2 to 0.95, right?
Yes, sir.
Now what the question asks is, when it is increased to 1000 kPa, what will happen to the voids ratio, right?
Yes, sir. Yes, sir.
Now you know that, as I said before, this line is a straight line, right?
Yes, sir.
So that is why we are taking the slope directly between, this is CC is nothing but y2 minus y1 by x2 minus x1, right?
Yes, sir.
Now you consider, now let me redraw this table for your understanding. So I can erase this. Now what I am doing is E and vertical stress. Now let me consider 0.95 is 600, right?
Yes, sir.
Now vertical stress is increased to 1000.
Thousand.
Now what will happen to this one? Now from this table, already given table, you calculated CC, right?
Yes, sir.
Now with CC and with this table, you can calculate what will be the void ratio at
1000 K.
1000 kPa. And how will you cross check it? It should be lesser than 0.95.
Sir.
Understood?
Yes, sir.
Solve and check once you are whether you are getting 0.83 or not.
Sir,
Yes.
in that sum we do AV or not?
AV also you can do.
Okay.
But the problem with AV is the curve
Correct.
between E and sigma dash will not be a straight line.
Yes, sir.
So it will be a curved line. So you might not get a fairly accurate answer.
Okay.
Try with it once, with AV once.
Yes, sir. Answer comes.
You are getting right. So now you
Yes.
try with uh, now you try the same problem by calculating AV. AV is delta E by delta sigma dash. Difference in void ratio, but instead of logarithm, you do it as the same value. What is the value of AV?
6.25 into 10 to the power of minus 4.
Okay, so it will be 0.25 by 4, which is obviously 0.625, which is 6.25 into 10 to the power minus 4. And now you calculate E for 1000.
Zero point seven
0.7.
seven.
Are you getting?
Yes, sir.
Now why is this difference?
This is some current meter square per second also.
Y means when you draw curve sigma dash with E, right? The curve will be like this.
Even
It is not a straight line. So this value will be not accurate. Okay.
Okay, sir.
Moving to the next question. A clay soil layer 3 meters thickness with a coefficient of volume compressibility 0.18 centimeter square per kg. Change in applied pressure is 0.25 kg per centimeter square. What will be the settlement?
okay, settlement form. Clear height is equals to 3 meter. Coefficient of volume compressibility.
How you will solve this problem?
Settlement form.
Set.
MV into delta effective into height.
Yes. Delta H is settlement. Check for the units carefully. Convert this H into centimeters for simplifying the calculations. So you will be finding difficult to calculate centimeter square, but you can convert 3 meters to 300 centimeters easily. It will be 0.18 into 0.25 into 300, which you can write it as 0.18 into 300 by 4, which is 75. 75
0.134
will be 0.135.
meter.
Sir, 0.135 centimeter, but here meter. Okay. Okay, sorry. Okay, sir.
15.5 centimeters. 0.135 meters. All right.
Yes, sir.
Now coming to the next question. For an over-consolidated clay deposit, pre-consolidation pressure is 125 and the overburden pressure is 75. OCR of the deposit is. It's a fairly simple question. You can calculate very fastly. OCR is equal to pre-consolidation pressure by
By present pressure.
present pressure.
1.66.
125 by 75
75.
will be
1.66.
1.66
66.
approximately.
Right.
This for consolidated or normally consolidated?
Greater than 1. It is a
At what state it is?
consolidated pressure is.
It's already given us or consolidated clay deposit.
Yes, sir.
So it will be obviously greater than 1. Right? So this is a tricky question. The settlement analysis for a clay layer draining from top and bottom shows a settlement of 2.5 centimeter in 4 years and an ultimate settlement of 15 centimeters. However, detailed subsurface investigation reveals that there is no drainage at the bottom. The ultimate settlement in this condition will be. So please wait 1 second, wait please. So this problem we can solve in the next week since these concepts are not introduced to you. We'll move to the next question. Right. Is the screen visible?
Yes, sir.
Yes, sir.
So now try to solve this question. During a consolidation test, a sample of fully saturated clay 3 centimeter thick is consolidated under a pressure increment of 200 kilopascal. When equilibrium is reached, the sample thickness is reduced to 2.60 centimeters. The pressure is then removed and the sample is allowed to expand and absorb water. The final thickness is observed as 2.8 centimeters and a final moisture content is determined as 24.9%. The specific gravity of soil solids is 2.7. Find the void ratio of the sample before and after consolidation. Now please listen here. Listen carefully. So first of all, you try to conceptualize this question. That is, you convert in terms of figure. So there are 3 situations. First is situation A at time t equal to 0, right? This is the soil sample. What is the thickness?
3 meters.
3 centimeters.
3 centimeters.
3 centimeters. Now, coming to the next situation, which I am terming it as situation B, T equal to T1. What is happening is that a load of 200 is applied, which reduces the thickness to how much?
2.60 centimeters.
200 kPa, which is getting reduced to 2.6 centimeters, right? Now next what they are doing, situation C at T equal to T1. They are removing the load, right? Right or wrong?
Yes, sir.
Now what is happening? It is again expanding to a thickness of How much?
2.8.
2.8 centimeters. Now the final moisture content is given. That is, water content at this point is given, which is 24.9%. Right? Am I right or wrong?
Yes,
Yes, sir,
sir.
right.
Now, what is the other data about soil which is given?
It is fully
Specific,
saturated.
Specific
specific
gravity
gravity
is given
2.7.
2.7.
2.7. Now, you have to calculate void ratio of the sample before and after consolidation. So, to calculate this, first you have to decide which is the point at which consolidation is getting over. Consolidation is getting over at point B or C?
B.
Why?
As well.
Why it is?
Load is
Yes, you are right. So, after B, the load is being removed. So, it is not, it is unloading. So, the completion of consolidation is, one cycle of consolidation is up to B. Understood?
yes, sir.
Now, this is, let us say, E1. You need to find E1 and you need to find E2. That is the question which is given, right?
Yes, sir.
Now, how will you find? How to proceed further? Any idea?
The loading settlement. Settlement only load thickness. Actually, XCC. XCC. Sir, we use the formula HCC by 1 plus E log. Okay. Increment pressure is there. But,
But how will you calculate the existing pressure?
yes, sir. Existing pressure we don't calculate.
How will you do? Now, what we have to do is, we have to back calculate. You know, you have to back calculate. You have to, you know, this data. From this, you have to find this one, and once you find this, you have to find this one, right?
Okay.
Now, can I write this?
Delta A by 1 plus E naught is equals to AV delta H by H.
Can I write this?
Yes, sir.
Now, you consider situation B to C,
Okay.
and what you need is, you have water content here and specific gravity here. Can you calculate E?
Yes, sir.
How much is E?
E, e into S. Okay, okay. 8 million 0.24 into 0.67
0.
at E3. 6, 7.
6, 7, 3. Now E naught is initial.
Yes,
So
sir.
this is final for when the action takes place from B to C, right?
Yes, sir.
Now can I write like this?
Changing weight ratio 0.673 minus E2 by
Can I write like this?
yes, sir.
Why I am writing like this?
Because E3 is the final void ratio and E2 is the initial void ratio.
Sorry, this should go here. Sorry.
2.8 minus 2.6.
2.8 minus 2.6. So how much is the E2?
Sir, where H is the initial length.
Initial height, huh?
Okay.
Now we are considering only B and C.
Yes, sir.
Now if you consider B and C, which is the initial thickness? 2.6 is the initial thickness.
Sir.
So that is why we are using H as 2.6. Understood?
Yes, sir. Understood.
How much you are getting E2? Are you understanding or not?
Yes, sir. Understood.
The other
And
person,
E2 equals
Yes,
to
sir, understand.
0.55.
E2 is
0.558. 0.5548.
0.55 will be
48.
0.55. Right.
Yes, sir.
Now you know E2. Now in the similar way, can you calculate E1?
Yes, sir.
How will you calculate? What is the relation you will use?
Same relation.
That's what you say. What will you substitute?
Change in 0.55 minus E1 by 1 plus
55
E1.
minus E1 by 1 plus
E1,
E1 equal
which
to
is equals to 3 minus 2.6 by 3.
3 minus 2.6 or 2 minus 2.6 minus 3.
Okay.
2.6 minus
0.6
3
minus 3.
by 3.
Change in height. Sir, change in height means initial height minus final
Final
height.
minus initial. Final minus initial.
Okay,
See,
okay, sir.
you please listen here. Here for delta E, you are putting final minus initial, right?
Yes, sir.
Are you getting or not?
Yes, sir. Tell me.
For delta U, you are putting final minus initial.
Yes, sir.
In the similar way, for delta H also, you have to put final minus initial. In the both side, when
Okay.
you are using, you have to use the same uh, manner. Use in the same manner.
Okay, sir.
So now E1, how much you are getting? How much you are getting? E1.
Even
0.6.
yes, 0.67. But I
Take once.
0.667, sir.
0.603.
How much you are getting? 0 point?
Sir,
Ah,
okay. Hmm.
Sir, 0.603.
0.603.
Yes, sir.
0.6667, I think.
Just a minute. Let me solve once.
Okay.
You have to get 0.79. 0.79 is the right answer. So
Okay.
this will be 0.55 minus E1 is equal to 2.6 minus 3 is 0.4. 0.4 by 3 will be minus 0.1333
0.793.
into 1 plus E1. So this will be 0.55 minus E1 equal to minus 0.133
Into 1 plus even.
plus, or it will be minus
Into 1.
0.133 E1. Right? When you solve this, this will be addition, this will be subtraction. You will be getting E1 approximately
0.793.
0.79. This is the answer you will be getting. Right? Right or wrong?
Yes, sir. Right, sir.
Right, sir. 0.7 and 3.
Now we will solve one last question. The other two questions will be solving in the revision session, which will be happening after the next week sessions. 1 hour session will be there. We can solve at that time. This question we can solve and we'll close this session today. So you remember calculation of effective stresses?
Yes, sir.
Okay, now read this question. Soil investigation at a site gave the following information. Fine sand exists to a depth of 10.6 meters and below this lies a soft clay layer of 7.60 meters. The water table is, as I read the question, you try to draw the figure for the question. The water table is at 4.60 meters below the ground level. The submerged unit weight of sand is 10.4 kilonewton per meter cube and the wet unit weight above the water table is 17.6 kilonewton per meter cubes. The water content of the NC clay is 40%, its liquid limit is 45%, and the specific gravity of the soil solids is 2.78. The proposed construction will transmit a net stress of 120 kilopascal at the center of the clay layer. Find the average settlement of the clay layer. Now try to draw the figure. So this is the ground layer and this, sorry. So this is 10.6 meters. This is 7.6 meters. So this is fine sand. This is soft clay. Understood?
Yes, sir.
And
Yes, sir.
now the next part is water table. Water table is at 4.60 meters below the ground level. So it is approximately here. So which is 4.6 meters. Understood?
Yes, sir.
Now here the entire okay. Now what they have given is the submerged unit weight of sand 10.4 kilonewton per meter cube and above the water table the density is 17.6 kilonewton per meter cube, right? So the same submerged unit weight you assume for this also, for clay also. Just a minute. So is my screen visible?
Yes, sir.
Right. So let us try to solve this problem quickly. Now submerged weight here also you assume it as 10.4 kilonewton per meter cube, right? Now next option is the water content of NC clay. These are all given. 40%, liquid limit is 45%, and specific gravity of this is 2.78. Understood? Understood or not?
Yes, sir.
Now what they have given,
Yes, sir.
the proposed construction, one construction is taking place, and due to this a net stress of 120 kilopascal at the center of the clay layer, that is delta sigma is 120. Now why at the center of the clay layer? Any guesses?
The total average, the
Yes, you are right, you are right. The average settlement, if they ask average settlement, you have to calculate at the middle of the clay layer,
middle of the layer.
right? So this will be middle of the clay layer, which will be 3.8 meters, right? Now from water content, what you can find?
What's sir?
From you have water content and specific gravity, what you can find?
CC.
That you have liquid limit. Okay, from liquid limit you can find Cc.
Yes,
Calculate
sir.
Cc.
Zero point zero four five.
0.
045.
Are you getting the same value or you are getting other any other values?
Yeah.
Okay. Now you have water content and specific gravity. Now you have see you have to find average settlement. Average settlement is delta H. Delta H is Cc by
HCC.
1 plus
1
E
plus
naught
E naught.
into H into logarithm of sigma naught dash plus delta sigma dash by sigma naught dash, right?
Yes, sir.
Now you found Cc. How will you find E naught?
E into SR equals to W into G.
Yes, find E naught.
Where E naught equals to 1.112.
Okay, waiting
Rather
40
long.
to 2.78. 0.4 into 2.78. Yes, it is 1.112. Right. You have this one. You have this one. You have this one. You have this one. Right. Any confusions? Please respond. Hello.
No, sir.
See, please respond. So these types of problems these models of problems you can surely expect in your exams to come.
Distance is long.
So you
Sir,
have,
we have a small doubt. A
yes,
lawn or log, sir? Log,
This
I
this
think.
is ln only.
Ln.
Natural
Log to
log.
the base. Log to the base 10 means ln, or log to the base
Log to
10.
the base e.
But
Okay, sorry. This is log only. Hello,
sir,
this is log only.
Yes.
okay,
So
sir.
you have delta sigma dash, you have cc, you have h, you have e naught, right? Now you need to find sigma naught dash. Sigma naught dash is how much is the effective stress is acting due to the overburden up to the center of the clay layer. How will you find this? Sigma dash naught dash is equal to 17.6 into
2 points
4.6
plus
plus
10.4 into
10.4 into 6
6,
plus
10
10.4
into 3.8.
3.8. How much you are getting?
182.88.
You are getting
182.88.
82.88. Now you solve, now you substitute this value here and you get the answer for delta H.
Yes, sir. The delta H is equals to 0.035 meters.
It is 0.035
0.35 meters.
meters, which is approximately 35
35 millimeter.
millimeters. So
Yes,
this
sir.
is delta H. Understood?
Yes, sir.
So the next two questions are a slightly extension of these problems, which we will be solving in the maybe in the next session or the session after that. So two sessions are left after this. So next week will be the last week, and after that there is one summary in which I will be giving the overall picture of the subject, and with that these sessions will be getting over. And with this, for the present week, I will conclude the session. Thank you for attending. Thank you.
Thank you, sir.
You can leave the meeting.
1, 2, 2 weeks.